Okay, so we're gonna go over two examples from the homework to teach you guys about how to use the functions to find test statistic and the p-value. So our first example, there we go. Okay, so in the 1980s, it was generally believed that the Ebola affected 77% of large nations' children. So looking at this, whoa, sorry, this is wrong numbers. Okay, so looking at this, we're first going to look at what is the null hypothesis and the alternative hypothesis for this question. Okay, so can anybody tell me the null hypothesis for this? So the null hypothesis is something that we make so that we can reject it. So if we reject the null hypothesis, we're going to be able to find out something and change maybe like a marketing plan or change a drug or make that drug into effect. So we want to set up a null hypothesis that we can reject. Hopefully we can reject it. So it's generally believed that 77% are affected by this abnormality, right? So that is going to be our null hypothesis because we want to see if this number has increased or not. So P equals 77. That would be our null hypothesis, right? And then in this case, what would our alternative hypothesis be? Oh, wait. Sorry. Okay, so what would our alternative hypothesis be? Yes, because we're saying some people believe that the increase in the number is going to increase these abnormalities. So we're seeing if it increased or not. So our alternative would be if it's greater than that. So would this be a two-tailed test or a one-sided test? One-sided, because it's greater than, right? If it was not equal to, if the alternative was not equal to, then it'd be a two-tailed test. Okay, so now that we've gotten these, I'll just go through how we find the test statistic and p-value. So in your R-help page, there's a really good function that we can use. So in here, there's two ways to do this. There's this kind of like step-by-step way, and then there's this really big chunk of function that we can use to find actually a one-step way to find all of the things that we need. So what I'm going to do is I'm just going to copy this whole thing onto my R. So this is going to give our function, so I'm going to run that. After we run that, we're going to look and find this function, z-test function. Do you see this one right here? So this is our function that's loaded onto R Studio. And if we look at it, it shows us how we're going to use it. So in the parentheses, we're going to have p hat n, which is the sample size, and p naught, which is our true proportion. Okay. So to find the test statistic and the p-values of this question, right, we need to figure out what p hat is. Whoa, I can't find it. Okay.
You know what the p hat is? That's the sample statistic.
So p hat is what? Can you repeat that?
Sample statistic.
Sample statistic.
Sample proportion.
Or sample proportion.
P hat is a sample proportion, which is a sample statistic.
Yeah, so it's what we observe, right? And then P naught, which is the P0. Do y'all know what that is?
Population parameter. So
yeah. Yeah, so like true proportion. I can't spell today. And so that would be what we usually claim is true, or what we see like throughout history we've seen something. So that would be a P naught. And then a P hat would be if we actually took a sample and observed how many out of how many to be true, right? So that's the difference between p hat and p naught. And in this question, whoa, what was that? So in this question, what is our p hat? Right. So our p hat is going to be, out of 358, we found that 44 were affected, right? So we do 44 out of 358, and that's our p hat. What is our p naught? 0.77. Okay, so literally we're going to do, how we use this function is ztest.p, parentheses. We're going to put in this p hat value. Let me run that. And then p naught, run that. So p hat. And what is our n in this question? 358. And then we're going to do p naught, which we put in as 0.77. And we're going to run that. After we run that, we can see in our little results, we can see the test statistic, p-val lower, p-val upper, and p-val 2. So what this means is p-val lower is when it's the p-value for when we have a lower test. So if we want less than something, we're going to look at this. And then p-val upper is when we want at least or greater than, we're going to look at this p-value. And then if the alternative hypothesis is just a two-tailed test, not equal to something, then we look at the last p-value. So in this question, our null hypothesis was greater or equal to, and then alternative was greater than 0.77. So which p-value should we look at? The upper. Awesome. So that would be our p-value. Wait, that looks kind of weird. Hold on just a second. So, sorry, the problem was written wrong. It should have been 7% of the large nation's children, not 77. Sorry about that. And so all we just need to fix is our p naught, which is 0.07. So the question was copied wrong. So the p naught should be 0.07. And so we're going to run that again. Sorry, guys. There we go. And so now if we look at our p-val upper, right, that's a very small number, and we can just say that that's 0. So can we reject this null hypothesis? Yes. So if we reject it, what can we conclude? Yeah, so we can say that the alternative hypothesis is true because we rejected it, right? And so we can say that there is an increase, and it increased, and it's greater than 0.07, not 0.77. Okay, so that's how we go about that question. And, okay. So yeah, and also we want to go over how we interpret p-value, right? So p-value is the probability of seeing a sample like the one that we observed, right, in the natural world, assuming that our null hypothesis is true. So that last part is really, really important when we interpret p-value. So we always assume that the null hypothesis is true when we interpret the p-value. So there'll be a question in the homework dealing with interpretations of p-values, and we always need to remember that we assume that the null hypothesis is true.
So I'll give you an example. If you say that the proportion of the probability of something happening, or the percentage, is around 40%, right? And when you do a test on a sample, you find that it is 38%. Yes, you believe that it's 40%, and you find it that it's 38%. So do you think normally 38% would be attributed to normal variations? I mean, normally it varies, right? If it's 40, it should vary between 35 to 50, 30 to 60 something, and it should be around about 40. But if I say it's 40 and you find out that it's 10%, then that's very unlikely that if you say it's 40 and you find out it's 10, then your initial assumption is wrong. Right? So that is what we test here. How far is your value from the true value, and is it possible that that change can be attributed to normal variation? Did you understand that? Okay, so I say that the average height of a UT student is 5 feet. Okay, and you do a random sample testing and find out that the average is 5 feet and 2 inches. So is that normal? Yeah, because 2 inches plus minus would, you would say ki it's okay. I mean, due to natural variation you might find 2 inches variation, but what if it's 6 feet? Yes, so it's too far away. So if it's too far away, then maybe your initial assumption wasn't true, right? Maybe the average isn't 5, it's somewhere closer to 6, right? So that's what we are testing.
So the 6 bit will make the p-value really small. So that's why we
The p-value is very small if your actual sample proportion is closer to your true proportion. So if your sample proportion is 7%, oh sorry, if your population proportion is 7% and your actual proportion is 6.5%, then your p-value will be very, very low. Yeah. Oh, it'll be high, so you can't reject the number. Sorry. And if it's very high, I mean very low, like 0.0000, so there is a 0.0002% chance that this can be attributed to normal variation.
I have a question. So
Yeah.
you're just doing one sample to find one p-value. So is there any case that two, we do two samples and we find two values that's different?
Yeah, you'll find those are different, right?
But what happens if the first one p-value is big?
Yeah.
So we fail to reject, but the second one is too small that we rejected. Is there any because of that?
I mean, that depends. If you have a normal curve and you take a random sample, then your random sample can be totally distributed in the sample and you will get your mean or your proportion closer to the actual proportion. Or if you are very unlucky, you can have, so for example, if you want to take the heights of UT students, if you go to SAC now and pick a random population and find out their height, that average would be closer to your actual assumed average or actual known average of 5 feet. But if you go to the Gregory gym and you decide to take the sample of the people on the basketball court, do you think, yeah, so that'll be higher. So you'll think maybe no, maybe that sample is higher. So that is possible. So that's why you do a random sampling to reduce your bias.
So we should do more samples. The more the better.
Yeah.
Okay, any more questions? Okay, so let's do a second example. Okay. All right, so in a recent year, a poll asked 2,963 random adult citizens, and in the poll, 15 rated that the economy was excellent/good. A recent media claimed that the percentage of citizens who felt that the economy was in good, excellent shape was 11%. So does the poll support this claim? So, just a second. So first we need to see what our alternative and null hypothesis is, right? So what are we trying to prove, wrong or right? I mean, what are we trying to prove, wrong or right? Which one? Is it in a recent year a poll? Are we trying to see if the poll's right, or are we trying to see if the media outlet is right? We're trying to see if the media outlet's claim is right or wrong, right? So that's where we need to base off our numbers off of. So HO, our null hypothesis, would be that it's 11%, because the media claimed that the percentage was 11%. And then our alternative would be what? Huh? Right. So is P not equal to like that? So that would be our alternative hypothesis. Okay. So to find the test statistic and everything, we do the same thing. Okay. So example 2. So we do the same thing, z-test.p. So in this case, what is our p hat? 15%. So we would just do 0.15. What is our n? 2963. And our p naught is 0.1. Yeah. And so we just go like that. And then we find that the test statistic over here. And also, is this a one-tailed or two-tailed test? Two-tailed, right? Two-sided. Because it's not equal to, we can have both ends, right? And so we would look at this p-value, right? And we can see that that's really small. So we can probably reject this and conclude that we have enough evidence to say that the percentage of citizens who felt that the economy was in excellent good shape is not equal to 0.11. Okay. I think that's about it. Yeah. So are there any more questions regarding these examples or anything that we've covered today? Okay, so I'll just, yeah, okay, all right.